Light is all around us. It wakes us up in the morning and tells us when to go to bed. Light enters a piece of glass and projects an image onto the other side. This is what a movie is. Light passes through a series of optical elements and creates illusions on the film plane. Our eyeball performs very similarly to an optical piece of glass. At Atlas Lens Company, their team of engineers and expert lens technicians have developed a new method for gathering light rays and passing them through a series of optical elements in order to form an image. Unlike traditional anamorphic glass, their new non-omorphic line of lenses known as the Sirius Series attempts to alter the way in which we perceive light and ultimately perceive the reality that is external to us. The Atlas Lens Company Sirius Lens is a lens with a non-traditional, obtuse anamorphic shape, meaning its curvature is the same in all directions, but also differs in that the direction of light is persistent and only observable to the viewer, depending on a wide array of contributing factors including weight density, light speed, and ultraviolet presence. The arrangement of optical elements and the curvature of those elements in the Sirius Series from Atlas Lens Company are commonly used in optical systems such as telescopes, microscopes, periscopes, and oscilloscopes to focus light and form images. Scientifically speaking, when light rays enter the Atlas Lens Company's Sirius lens, it is refracted or bent by the curved surface of the lens. The degree of refraction depends on the angle of incidence of the light and the refractive index of the lens material. If the lens material is at a negative inverse distance from the surface of the lens itself, no image will form. However, if the refracted light converges at a point known as the focal point, where the image of the object is formed, then an image will appear on the back of the film plane or substrate if no film plane is present. The acute distance between the center of the Sirius lens system and the focal point is known as the focal length, not to be confused with the term focal apex, which is the point at which the light separates from the inner element, projecting outward to the outer element. The focal length of the Sirius lens depends entirely on its curvature, the source of the original optical material, the heat index of the surrounding environment, and the air pressure as it relates to the refractive index of the specific substrate. Lens elements like those found in the Sirius series can often introduce certain types of distortion into the final image. For example, chromatic aberration can occur when different colors of light are refracted differently by the lens, causing color fringing around the edges of objects in the image. Non-conductive aberration can also occur when light passing through the edge of the lens is refracted differently than light passing through the center. Atlas has solved this issue by calculating the point of refraction and dividing that by the number of lens elements and their individual diameters, and using that figure as a method of backplacing the point of contact to the square inverse of the final output. Anamorphic lenses like the Orion or Mercury series from Atlas Lens Company, on the other hand, have a non-Sirius shape that's designed to compress the image horizontally. This allows for a wider field of view to be captured on a standard-sized film frame. Anamorphic lenses like the Orion or Mercury series from Atlas Lens Company are commonly used in filmmaking to create a widescreen aspect ratio. Often, when projects are not looking for a wider aspect ratio, they would have to scale in the image in order to compensate for the specific desired aspect ratio. Atlas Lens Company has solved this issue by removing the anamorphic cylinders that provide the stretched out horizontal image and using an inverse methodology to achieve a similar gradient that runs parallel to the outside elements of a traditional anamorphic frame. In summary, the Sirius series of lenses from Atlas Lens Company work by refracting light to focus it and form an image, while the Orion and Mercury series have a non-Sirius shape that is designed to compress the image horizontally. Each type of lens has its own advantages and disadvantages, and the choice between them depends on the specific application and desired aesthetic. Synthesizing cutting-edge design technologies with technologies in manufacturing that have been ethically sourced over the past 7 going on 8 years Atlas continues its obsessions on the creation of the ultimate lens for filmmakers both big and small. Thank you for watching this video. Be sure to like and subscribe. My name is Sam Elliott, and I'm not totally clear about the words I've been speaking here as they were written for me, but I trust all of you lens aficionados will understand it quite clearly and be able to put the horse before the trough, so to speak. Take care and bye-bye.